Good? Alrighty, can everyone hear me? Good? Can everyone hear me or should I use the microphone? Good? Use it? Alrighty. So, I want to say thank you to everyone for coming. Hopefully everybody's having a good time so far at Hack Miami. I want to say thank you to Hack Miami, and I think Dave's downstairs, but thank you to his keynote. So hopefully you're here for the Router to Success, Hacking a Router to End a Life. My name is Austin Turecek. Today I'm going to be doing a quick little presentation discussing a router that I went through, did a security assessment through, and ultimately ended up finding so many vulnerabilities that the company chose to completely remove from the marketplace. So just a quick little introduction, an overview of the presentation. I'll start to introduce myself a little bit. I'm just going to go over kind of my background. I'll start a timer real quick so I know where I am for time. Just going to do a little introduction as to who I am, kind of some of the experience that I used throughout this. Then we'll introduce all of us to the actual target itself. Kind of talk about why I chose it and some of the interesting features built into it. We'll go into the actual hacking process itself, and then we'll close it up with the responsible disclosure and what that looked like in the terms of this engagement. So just a quick little who am I. My name is Austin Turecek. I'm a senior application security consultant at GuidePoint Security. So as an AppSec consultant, a lot of my time is focused on application security. So web and API components are pretty much what I focus on. That being said, I pull a lot of, oh god. I'm going to move this over a little bit so I think this keeps, there we go. This will come back up, hopefully. So this would be a great point to highlight. We're going to be talking about IoT and embedded hacking, and a big part of that is hardware. While I do that, I'm currently having some issues with the hardware, and we're not going to talk about it during this. So outside of the application security, I also do quite a bit of IoT security at GuidePoint. We have a number of different services that we look to offer, and that of course leads to embedded system security. A lot of my work in that realm really just came from the independent study and hunting that we're going to see today. Outside of that, I'm a big proponent of open source security. If you are a GitHub maintainer and you ever see that little icon pop up within a pull request or an issue, know that it's probably me and know that you probably have a vulnerability. But do not worry, I'm going to do everything I can to work with you to fix it. Outside of that, I also have experience with malware analysis and deep and dark web intelligence. Before I came on to GuidePoint Security, I worked for a company called Flashpoint Intelligence. Completely unrelated, despite the points in both of them. There, I spent about 2.5 years just roaming around the deep and dark web, playing with malware, getting to know all the lovely criminals that we try to fight against every day. Some really nice people if you take the time to talk with them. And then, of course, just basic system administration. And what we're really going to see is throughout this entire process, I'm going to be leveraging all of these different skill sets to really go through and perform this entire assessment and perform the hack that we'll talk about today. So the target itself is the N150 wireless travel router, TEW714TRU. It's made by Trendnet. These are directly pulled from their site to explain kind of the device itself. So share a single internet connection with multiple users. It's great if you are in somewhere that say just has a single Ethernet port. You can plug this in and it operates as a small temporary router, number of different components, also the WISP and the repeater modes. One of the areas that we're going to be talking a lot about is within the device, it has a USB share feature. And now this feature is, think of it as a quick and easy file share server. You can plug in the USB drive, you can connect it to the network, and then you can share those files with different people. There's different controls about that, around how that's done. We'll talk a little bit about that. It also has the charging port for your phone, interchangeable plugs for the travel person on the go, a one-touch network connection with the WPS button, because we all know how secure that is, and energy-saving green net technology. I have no idea what that is. When I looked on their site, it just says it's good for the environment. I have no idea what that means, but it doesn't really impact the security. So just looking at some of the basic features, this is the actual web UI. So an important thing to note with this device is that it is sold as a router with a control panel that is accessible via the web interface. There are allegedly no other control panels or interfaces that a user or an administrator could use to interact with. So as mentioned earlier, it operates as all of those different components. The USB storage feature, which you can kind of see right there, has actual controls around it to try to provide better security as to how your files are shared. And a thing to note is it's built on BusyBox. So for those who may not be familiar with IoT or embedded system, BusyBox is a very lightweight Linux distribution that is specifically designed to be cheap and lightweight on a system, especially when you have a system like this where memory is limited, storage is limited, and you need to optimize all of that stuff. So let's actually talk about the hacking process. So I ordered this at the height of COVID when I was stuck inside like the rest of us, and I just kind of got bored at looking at malware every day. That doesn't sound familiar from our last talk. And I really wanted to try to expand on some of my skill sets, so I just started to go around Amazon and buy as many of these cheap, low-cost routers, IoT devices as I could. Basement where I tested started to look like just a hoarder's den of technology between wires and soldering things and tons of devices like this, and one's far bigger. But I ended up getting this one off of Amazon because it was like $10. I was like, hey, I can afford that. Let's buy it. Now, as soon as it came in, I did what any good network pen tester would do, and I immediately started with an out-of-the-box network scan using Nmap. Now, one thing that's very important to consider when looking at IoT and network-based, IoT and embedded systems is in many cases, they're going to have different states that are very heavily controlled by the environment around them. So the biggest controlling factor that this one had is that USB share feature. When we plug in a USB drive, the state of the device changes in such a way that there are new components, there are new services. So right out of the box without the USB drive, and when we scan the device using Nmap, we get a total of 5 ports. Mind you, the HTTP web service is supposed to be the only one that is available and presented to administrators. Despite that, we found a lovely Telnet port running on 23. The web service that we expected on port 80, which uses Go Ahead. We'll talk a little bit about that, a little bit more about that later. An unknown service running on 8087, another HTTP service on 8098, and universal plug and play on 49152. Now, universal plug and play is pretty common on these devices, and the expected web service is running on port 80. That's to be expected. We might like to see that running on a secure port such as 443 with HTTPS, but they didn't. Everything else here is a bit concerning. The fact that there's a Telnet service, the fact that there's an unidentified service, and another random web service are great indicators that there might be some more interesting findings and some more valuable exploits that impact this device. Now, once we plug in the USB drive, we then get a couple more ports, FTP, and 2 SMB related services. None of these are using encryption at all. So that's right off the bat a very good indication that there's probably going to be some issues in terms of the security. They haven't taken the necessary care to use encrypted services. And not only that, but they also have a number of these services that weren't being told to the user, to the end consumer, which suggests that there might be hidden functionality or potentially debug and development services which were left open when sent to production. So reviewing those available services, started with the Telnet service. The admin account that came with the device, it's nicely printed on the front here, didn't work. Moving to FTP, there was no anonymous logon, and the admin account didn't work. And moving to SMB, the admin account didn't work. Now, the first kind of thought there is, okay, well, I don't have access to that, how sad. But the second thought there is, why the hell would they leave these up then? If I don't have access to them, who does, and is there something I can do with them? It's not all that uncommon for organizations to just leave these types of services up and not actually have logins, so they're just kind of these exposed services, which if an unknown exploit were to come out that impacted those services, it might have impact, but outside of that, they're not really dangerous. Looking at the other HTTP service outside of the normal one on port 80, the one on port 8098, I was presented with a basic static page, and when we plug in the USB drive, it actually loads in this media directory, which ultimately loads all of the content of the USB drive. So this secure USB drive sharing feature they have is already debunked, it's already completely vulnerable, and it has no secure access right off the get-go. So that's really kind of the first finding we have, is the fact that they're not protecting any of this content, and all of this content is publicly readable by anybody who just goes to port 8098. So moving forward, we started to look at the actual web service that was advertised. Opening up a burp suite and intercepting that traffic, we started to see a large number of these very suspicious URL parameters. So I have 4 right here, and you can see there's this request to this form f serve x, and there's an szcmd parameter, and it contains fun things such as cat Etsy row web advanced PTI version, find Etsy row web media SDA1 max depth 1, echo var upload param, and then a shell script that appears to be executing. And when we look at the response from those requests, we can see that in this case, that find command outputs the exact output that we would expect from a find command if we ran it on the operating system. So seeing that, my immediate thought was, well, this seems like a great avenue for command injection. Maybe we'll get lucky and they just didn't do any type of escaping or sanitization. And sure enough, it was that simple. The basic vulnerability was just to take any of those commands, add a semicolon, and add the command we wanted, and we get back the username that would be output from whoami. Taking it even further, we just remove the expected command and we just provide in our own, and it executes it just the same. Making it worse, if we remove the authentication token, which is this cookie called xu_cookie, it still works. So we had unauthenticated remote code execution in under about an hour. So we did it, we're done. Of course, the kind of issue with that, just trying to get my time, we're only 11 minutes into this presentation, so clearly there was something else, and there was. So it's kind of important to do a little bit of research beforehand. I got a little too excited and just jumped straight into the device. And sure enough, there's this lovely article from ThreatPost, Travel Routers NAS Devices Among Easily Hacked IoT Devices. And this is the direct quote pulled from the article. Another device, a travel router made by Trendnet, TEW714TRU, also makes command injection easy, Horst said. An attacker can inject commands unauthenticated over a LAN port and combine them with a remote code execution vulnerability in another layer, he said. This one is quite bad, and I would have to agree with Horst here. Because it shows the architectural design of this device is not how it should be. You shouldn't be able to run commands like that. And I think most of us would agree with him on that. You shouldn't be able to run commands like that. Seeing that, I was a little kind of disappointed, and I went and did a little bit of research. I said, okay, what versions is this vulnerable to? And sure enough, it was the version I was running. So I went to Trendnet's site. That was kind of just a feeling. And sure enough, they had released a firmware in 2016. Excuse me, 2016. And the notes are very helpful for me. It just says security update. So seeing that, it was a little disappointing because I had about half this report already drafted up, ready to send to Trendnet, and sure enough, a researcher had already done all of this for me. I can validate Porsche's research at very least from this, but certainly there has to be more, right? Because no conference would let me come here and just rehash somebody else's research and be like, ta-da, especially in 15 minutes. So this one I had to go back to the drawing board, but I had a very interesting opportunity here. First off, I have firmware, so there's a lot of cool tools we can use to analyze that firmware, to further look through it, to really dig into it. And secondly, I had access to this device that they didn't intend to via this vulnerability. I have a remote code execution vulnerability that can allow me to interact with and exploit the operating system. Now, while firmware is great, and we'll talk a little bit about how we can break that down and look at it, one of the issues with many firmware is that the data within that firmware is rarely the data that is running exactly on this device. In many cases, developers and manufacturers will include components on these devices and within the storage that don't get reflected into the firmware. In some cases, that information can be very, very useful. So I decided to start and really take a look at the firmware that was provided by Trendnet, and this is the updated firmware. So we use a tool called Binwalker. Binwalker is a relatively powerful tool that's really, if you're doing any type of IoT or embedded system analysis, should be within your toolkit. It's essentially just a deep hacker for firmware. It has support for a huge number of commonly used formats and can go through and break out and pull out notable files and pieces of information from firmware itself. Now in this case, I ended up having to run the extraction process 3 times to extract the underlying operating system. I will note, Binwalker does have an option, it's the -M, it's named after like the Russian nesting dolls, that allows it to go through recursively and extract them all on their own. But I'm personally a big fan of going through and doing each step manually in these cases because I get an idea as to what's here. So the first run, it identified a UImage header and an LZMA compressed data. That compressed data is likely going to be the operating system, kernel information, and potentially other information related to the actual firmware. This second process, as we can see in the second photo, ended up pulling out a Linux kernel 2.6.21, several paths, some tables used for mapping out the firmware and compressed data. And then the final decompression identified the actual directories and files associated with the BusyBox, the Linux distro that the device was running, and I was able to pull out all of those files. So at that point, I have at least some of the files that are going to be executing and operating on this router. And I had the opportunity to go through. Unfortunately, just going through those files, I didn't see anything that was necessarily too egregious in terms of security issues. Which kind of makes sense because in this case, this firmware update is being used to patch maybe a handful of binaries on the device, specifically those that allowed for the remote code execution vulnerability we saw earlier. So before we actually updated with that firmware, let's explore the system. So using the remote code execution vulnerability I identified, or rather Horsch identified some 4 years before me in 2020, I decided to go through and look for low-hanging fruit. Within a lot of embedded systems, it's not all that uncommon that there are keys, certs, or hard-coded accounts embedded within those systems. This really comes into the idea of security through obscurity. These hard-coded accounts aren't really an issue unless somebody can find them. And when I looked through the firmware that was provided, there were no hard-coded accounts, there were no keys that I identified, there were no certifications that seemed interesting to me. So going down the list, in terms of keys, there wasn't really anything interesting that popped up. In terms of cert, there are no secure services, so there's really not much of a chance for those to be there. But there were a number of hard-coded accounts. So a quick cat/etc/password revealed the contents of that file. Now those of you who do a lot of Linux administration may go, aren't those things supposed to be stored in the shadow file? And generally, yes, they would be. But BusyBox and a lot of other very lightweight distros will default to storing this information within the etc password file just to decrease the amount of necessary memory. And from that, there were a total of 4 unique accounts that were present. The first one was an admin account, which I already had access to. I'd already played around with that, and it didn't really have much. The next one was a root account. That's obviously the one that I want. Then there is this 7018N account. I have no idea of the importance of those numbers or letters, why they chose that. And then there's an FTP account. So with that, at that point, I have hard-coded usernames and their password hashes. Using John the Ripper, just did a basic John user account hashes, and John was able to successfully identify one account. The FTP account had a password of 7018N, the username from the past account. And luckily for me, it had telnet access. Why it had telnet access, I don't know. So right off the bat here, we now have access to the underlying operating system with a couple caveats. Unfortunately, this FTP account was a very low privilege user. It had the ability to read files, which could expose some sensitive information. It had the ability to execute some files, but it didn't really have any write functionality. It was a very low privileged user. And I started this having access to the high privilege user, and I wanted that privilege back. I didn't want to just go from this high-end user down to something low again. But I still noted it. Having telnet access was great, especially because these aren't advertised in the device. There's no way to change these in the web user interface. So that means all of these 3 accounts, the root 7018N and FTP account, are going to persist there regardless of what the user does, unless, of course, they find a remote code execution vulnerability, go in and change it themselves. So, with that in my pocket for maybe later use, I started to go through the administrative panel again after the update, just to see, again, kind of cover some of the components that stood out, has the ability to manage logs, has the ability to manage users, and it can interact, users could still interact with the USB drive. And what I found very interesting is after that update, a quick check of that port 8098 found that it was still open, which told me that not only was the USB component untouched, they didn't fix that issue. It seems as if Horst he likely stumbled upon, or not stumbled, he found the remote code execution vulnerability, reported it, and Trendnet did their due diligence to fix that issue. But it doesn't look like some of these other issues were reported. So seeing that, I really started to look into the USB component of it. When we think about the functionality, it's got a listing component, which is useful, if not relatively secure, but also it has the file upload component. Now this file upload component is controlled by various user levels. Some users are allowed to upload, some users are just allowed to download and look at the files. And like I said, it remained untouched after the update. So I was really curious to see what they may have done. We saw part of the issue with the remote code execution in the last vulnerability, which was patched, was the fact that if we just remove the x_u cookie, this one right here, we could still send unauthenticated requests to the router, and it would process those requests. So my hope was that there might be areas, other areas within the router, such as this USB one, where they may not have addressed those issues. And when we look at something like this, the ability to write files onto the system has a lot of potential value. If we can go through and arbitrarily write files, we can replace important binaries, we can replace user files, we can do a myriad of damage which might elevate our privileges to a higher privilege. And when we look at this request, again, this is pulled from Burp Suite, there's a couple of very interesting components here. So this was a request where I simply uploaded a file named test, and the contents are, I am a test. So we can see the contents of the file here. The file name is listed under the file name parameter, and the ultimate form within that is the uploaded file form. Many systems would simply take this component of the request and process that component of the request. Especially, we're writing to a USB drive, we know where that USB drive is being written to. So really, there's no reason to take any other information outside of just writing to that directory. But what stood out to me was this dest path parameter. It's a little hard to see, especially from the back, but essentially what this is doing is this is passing the directory, the file path /media/sda1/test. So from the earlier issue in terms of the service on 8098, we saw that that is the same directory that the USB drive is being saved to and written to. So what that means is there's a very real chance that this is being used as the path to write that file. And if that is in fact the case, then there might be a full path to, there might be a path to patch reversal which we could potentially use. And sure enough, there was. And not only was there a path to a route to patch reversal, it was also unauthenticated. As I expected, it really seems as if Trendnet only took the findings that were presented to them and applied those authentication fixes to that component. So the components which weren't really looked at in past research, i.e. the USB upload component, didn't have that same level of security and due diligence applied. So in this case, I'm passing a request where the authentication token, the XU_cookie, equals no valid. And instead of passing that USB directory, I'm now, within the dest path, I now just pass a test2.txt file directly to the root directory. And when we do that, we get this fun little test2.txt file in the root directory, and it contains this entire form within the file itself. So what we found here is an unrestricted file write, which allows us to overwrite any content on the server. Now, there is a bit of an issue here, and it's that we are stuck with all of this form data, which is a bit unfortunate because it really limits what we can actually do with this. Now, this is going to be really hard to see for you in the back, but I just wanted to include this and use this as another plug to mention another really useful tool. This output is pulled from Ghidra. I mentioned earlier that the web service was running on a HTTP service called GoAhead. GoAhead is a lightweight web service that is actually really powerful when doing embedded system and IoT development, especially in C-based languages. It offers a relatively robust API that allows developers to directly map web requests and those parameters to C code in small sections of execution directly from the HTTP request. That makes it really easy for developers to take their code, whatever they want to do in C, and directly map it to an HTTP request. Of course, when you make something easy, it's also far easier to screw it up. But this is what that code looks like running it through Ghidra. Now, for those of you who might not have used the tool, Ghidra is an open source reverse engineering tool. It was created by the NSA. Highly recommend it. I'm sure they don't have any fun collection tools built into it. It is open source, and there are plenty of people looking at it, so I'm assuming one of them would have caught it or been paid off. So what's really nice about Ghidra, though, is we can take this binary, this GoAhead server, which is compiled with the custom code that the developers created, and we can break it down to a primitive form of C. Now, the alternative to looking at this mess of code, and this one's a little bit easier to see, you can even still see it's kind of messy to look at. The alternative is to look directly at assembly, which I did malware analysis for 2.5 years. Nobody wants to look at assembly for any length of time. And if they tell you that, run. They're scary people. So this all here controls, and there's some of it cut out, controls the actual file write operation. So just walking through, the process that I used to find this was relatively straightforward. After loading the GoAhead binary, which I obtained via the firmware extraction, I started to look through the firmware, the GoAhead binary, for some of the keywords we see in here: desk path, uploaded file, file name. And when I did that, I ultimately found this one little snippet of code, which right here includes the file name equals. And what the code is doing is it's going through and it's parsing out that web form that we saw. And it's ultimately just doing some basic, a lot of this is just kind of basic memory handling to build the buffers and handle the necessary components for the file write. But once we get to that point, it opens up a file called /var/__upload param, which we saw in an earlier request. And there is commented out JavaScript code within one of the components that also makes reference to that, which again further points to the thought that there are debugging components that these developers never actually removed. Instead of removing the code, they just commented it out because then it's secure and it's not going to execute, and there's no way a hacker looking at it could find it. But moving forward, moving through that, it does some basic file writes. And then my favorite line in this is this very small one right here. It does a comparison of the provided file name you give it. So in the case of this one, the test2.txt, and it compares it to /media. If the provided file path begins with /media, it goes and it continues to write to that media drive. If it does not, however, it jumps to this code where it just writes the file anyways. So they made a conscious decision to look at the code and go, where do they want it to write? Do they want it to write to this secure location where we would expect? No, that's fine. We'll just write it anyways. I don't know why they did that, but it made my life a lot easier. Again, though, I really think this comes down to some type of debugging or development code that they had in place. I wouldn't be surprised if they were testing other components. Maybe early on in the development, they didn't have like a fancy firmware upload function, so they would use this to upload it, and then they just didn't remove it. I really don't know. Trendnet didn't give me answers in terms to that, which you wouldn't expect them to. But it was just such a wild concept to me that they had the solution. All they had to do was take this line and said, okay, if that first string doesn't equal /media, we'll drop it. Again, there's other, you'd use directory traversal and other issues to get around it. But they still had the right idea, and then they just completely went the other direction. So, having a path traversal, the next thing I really wanted to do was turn this into a remote code execution. Now, and this is the path that I took to authenticate remote code execution. When we have a patch reversal vulnerability, one of the things we can usually do with it is we can take a file on the system, such as a binary, overwrite that, and then when that binary is executed, our code will execute. There were some restrictions I had to contend with, though. First, it can't be a binary. We saw, I'm going to go back. You can't have a binary that looks like that. When the system attempts to load that into memory, it is going to crash, and no matter what the executable is, it's not going to work. So our executable file couldn't be a binary. It must be executed by the server in some way, and ideally, I was looking for something that didn't require authentication. I found something that fit 2 out of the 3 of those. I found something that wasn't a binary and was executed. Earlier in the presentation, we discussed one of the commands that was executed was the /etc_row web sh get diskinfo.sh. What would happen is when a user went into the administrative panel, whether they were an admin or a normal level user, they're presented with the USB feature. When they click that USB button, it would send this request, and this would gather some information about the USB drive to present back to the user. And this was just a basic shell script that was saved onto the system. And one of the nice things with shell scripts is they're pretty forgiving when we can run them. So I put together this basic exploit code. All we're doing here is we're writing, instead of writing to an arbitrary file now, we're writing directly to that getdiskinfo.sh file, and we're uploading an arbitrary script. In this case, I got the /bin, shebang bin bash with my command, and I'm piping that to a file called etsy_row web lang and shell. So that file doesn't exist on the server, but it does exist in a location where a user can access it in an unauthenticated manner. So what that means is we as an attacker could run this code. In this case, I do have code to actually trigger it and execute it through the authentication. But even if we didn't have authentication, if we could connect to the router, we could run this little snippet here, and then the next time an authenticated user clicked that USB function, our code would execute, and we'd be able to retrieve it in that shell file. And now if we did have credentials, like I've kind of demonstrated here, we could go through and we could just manually execute that ourselves and then retrieve it immediately. So this is just a quick little video to show what this actually looks like. So we can see we have the shell page that I previously mentioned. It returns a 404 site or page not found. We're going to go now and we're going to upload the shell. I'll pause this really quickly. We're overwriting that getdiskinfo.sh file with the command echo hello hack Miami to that shell file. And we can see the cookie, we don't have that XU cookie, but we just have unauthenticated equals true for the server. So when we send that, we get a redirect to an error page, but if we go to an authenticated session, which we have here, and we send a request to trigger that shell script, we get back a 200, and now when we request that file, we get back the message, hello hack Miami. So at this point, we now have an authenticated process to go from nothing to remote code execution with a higher privilege user. It's going to restart on me? Yes, it is. Okay, so let's tackle that pesky authentication problem. Remember, I started this with the non-authenticated remote code execution. I want to finish it with that. So the login process is relatively simple. You send your request to the login page, it loads the login form, you submit your credentials. If the credentials are valid, a request is sent to /temp/data.txt with a timestamp, as we see here. Else, if your credentials are not valid, it returns you to the start. So seeing that, I was kind of curious. I wanted to know, what is that temp.data.txt file? Because what I found is, when I looked at past, when I would attempt to grab that file after the authentication, 10, 20 minutes after the authentication, that file didn't exist on the server. But directly after that authentication request was sent, it loaded this file. It's admin, a new line, a random hash, a couple spaces, a dash, and then a new line character. And some of you who may have been paying attention to some of the other cookies, especially the XU cookie earlier, may have noticed that that is our authentication cookie. And what's really interesting is we don't need any type of authenticated session or any type of notable information to access that. All we need is a couple basic cookies that are set by the server. So, in essence, we have a way in which we can obtain this authentication cookie without actually knowing the credentials of the user. So this is how we can bypass the authentication. We just set up a basic while loop and we hit that server until somebody logs in. Once that happens, we get a session, we can run on their session. So even now, if they don't click that USB feature, we have the session tokens and we can do it ourselves. That's not good enough for me though, because that still requires a user interface to interact with the system. So let's actually make it worse. Now, IoT and embedded system analysis is a really careful blend between application, binary, and system security. So when you approach a target like this, I'm very AppSec oriented. That's my job. That's what I do. So I obviously like to focus in on that AppSec side, but it's incredibly important. Going back to the keynote speaker, generalists are very powerful when it comes to hacking. In this case, I started to really explore the system and look at the actual security surrounding the system with that Telnet account that I found, the FTP user. And looking at some of the more custom code and custom shell scripts, I found this file called validuserpassword.sh. And the process is relatively simple. It runs it sets a variable with the contents of nvram, with the output of the command nvram_get_login. It gets a password variable with the contents of nvram_get_password. It then takes 2 command line arguments, a user and a password, and then it compares those. And based off of that comparison, it'll either return OK or FF for forfeit, I guess. I don't know. But what was really interesting is when I ran that nvram get login and nvram get password with the low-level FTP user, it returned the admin username and the plain text password of that admin user. So, mind you, this is an account that is hard-coded into the system. There is no way for the user to actually remove this. So we have a path now to actively obtain the username and password of an authenticated user, of the admin user. Partly because of poor system-level security. There's a lot of things they could have done to really address this issue. First off, that file was actually never used by the server. I didn't really see anywhere where that valid user password was being executed. So if they just removed that, it would have been far more difficult for me to have found that command and actually identified the fact that that command was being used to return a username and password. Alternatively, I don't know what the FTP account is using, but I don't see why an FTP account needs to run some type of user check. If anything, I would expect that FTP user might be just isolated to FTP accounts and FTP activity, but evidently they allow far more permissive permissions. So with that, I now have a full path to execution. I can now obtain the admin username and password. I can now overwrite an important shell script, and I can now execute that with the said stolen username and password. So now, before, with the authentication loop issue, if they went through and they changed their password or logged out and killed the session, I can still continually retrieve those credentials. And this is a really fun combination of system and application level security. The system side comes into those hard-coded accounts, the ability to execute some of these commands, the presence of some of these commands. Again, I didn't really see anywhere in the application that was using this nvram_get binary. It may have used it in other components that I didn't really look at, but if it wasn't, there's really no reason for that file to be there. And then towards the application side, there was just a variety of different web application vulnerabilities that ultimately led to the full execution, the full vulnerability. So what I have here is the actual proof of concept code I wrote. I've done enough presentations and conferences to know not to trust the cruel deities that control demos. So this is a video of the actual exploit, and I will share where this code is located after. Is this running? No, it's not. There we go. So I'm currently connected to the router. I can run a basic IP config. And we can see my IP is .10.129, the router is .10.1. With that information, we now have enough information to completely compromise the device. So I start by running the basic script. We provided the IP. At this point, it goes in, it logs in with that Telnet account, and it pulls out the username and password as provided by those nvram get commands. From there, it does the authentication process and it grabs that session cookie. Once I have that, it's as simple as running that path traversal and clicking that USB button or executing the command that is contributed to that, and we now have a non-interactive shell in the system. So we can see files within the directory, we can see the etc password file, we can also see, in this case, I created another user called guest2. We can see the existence of that user, we can get that user's hash, and we can try to crack it. Essentially, at this point, we have full access to the operating system. I don't run a who am I, but this does run with the user. It's not the root user, but they have, they have the same level of controls as the root user. In this case, it's part of the admin group, which has access to all of the notable files related to the router's operation, configurations, etc. So we've now hacked this to the point where anybody can connect to it, can completely take it over. How do we go about reporting this, right? Obviously, this is a serious issue, and we want to make sure the organization is aware of it. So, Trendnet's actually really great with this type of stuff. I've reported a good number of vulnerabilities with it. I don't know if they like me anymore. I feel like they're getting sick of me. But on May 9th, this is 2020 again, I reported this vulnerability. May 11th, the support engineers were notified. I got a nice little message via their support page that, hey, we've let the engineers know. They're cursing your name as we speak. So on May 17th, Trendnet released a support page noting all of these different vulnerabilities and stating that the product has reached its end of life. 2 days later, I got an email from the director of engineering. I've been on an email chain for another vulnerability which I reported with them, and they said, "Hey, just so you know, we saw your report. We released a report. We're not gonna put out a fix because it reached end of life." And I was a little confused when I got that email because it was not end of life when I bought it, and it was not end of life when I reported this. There were some things I didn't check in this process, i.e. the past research, but I knew for a fact the device was still valid. So I looked at their end of life page, and sure enough, on May 17th, 2 days after they let me know that they weren't going to fix it, they decided to end of life it. And I've told this story to a decent number of people through interviews and whatnot, and a lot of people kind of give me the initial like, wow, why would they go about that? How irresponsible. But it's really important that we remember that the research that we do, bug hunting and whatnot, exists within a larger scope. If anything, I would argue that end-of-lifing in this case was the best business decision they could have made. So, really think about what this is. This is a travel router. You plug it into an Ethernet port, and then you share your Wi-Fi. Raise your hand if you have a travel router with you on this nice little trip. Raise your hand. Oh, wow, one person. Okay. Is it like one you connect through your phone carrier?
I don't.
No? Okay.
I was scratching my head, sorry.
So, not only that, but raise your hand if in your hotel room you know where the Ethernet port is. Yeah. So, in a lot of ways, this device is really from an era bygone at this point. If I need to get to the internet, I could surely connect to the Hack Miami Wi-Fi if I really wanted to. But I could just take out my phone. I could put on my LTE, my hotspot, and I can get that same network connection that I can get here. I want to share files with my friends. I can text them to them. I can email them relatively simply over LTE. This device was great for when it was made, back when that type of technology wasn't as popular or was far more prohibitively expensive. But in its current day and age, there's really not a whole lot of use for something like this. So when you think about the fixes that they would need to do, they would need to completely re-architecture the authentication process. Realistically, they could probably get away with just replacing like the temp data.txt with a set cookie header, but it's neither here nor there. They need to redo how they're handling authentication around the USB drive component. And remember, there are different user levels, so they have to go through and add additional checks to make sure that those user levels are properly controlled now. They have to go through and rewrite the components for the file upload. They have to go through and potentially, it would probably behoove them to go through and do like verification checks to ensure that the executing scripts are in fact the scripts that are designed to be executed. These are not small tasks. You have to get multiple engineers to work on these processes. And even once you have the update, you now have to put out notifications. You now have to reach out to users who might have this device, make them aware that there's an update. You have to walk them through that update process. If they're still using this, they're probably not technically adept, so it's going to be a pain to walk them through the update. And when you think of how much money and time that's going to be, it really makes a lot of sense to just throw the device away. You know, it would be nice if every vulnerability we reported had a fix for it, but that's not realistic. That's not a realistic route in the bug bounty world. And when you're going through and vulnerability hunting, sometimes it just makes more sense to just say screw it and throw the thing away. So just to wrap things up, I'm gonna do it on time. Oh, perfect timing. So we've identified a couple different vulnerabilities. Multiple authorization bypasses, one via the hard-coded account, which was another finding, one via the extra web service that they're running, and then one via the while loop process through the temp data TXT. We've also identified a patch reversal through remote code execution, and we've discussed Trendnet's response to end of life the device. Again, it makes a lot of sense for them to do it. And then if you are interested, this router is still for, I don't think it's actually for sale anymore on their device, but you can at least get to that page and kind of go through and try to find it in other ways. I don't know if it's still on Amazon. Trendnet does continue to sell some end-of-life devices as that. They purposely mention like, hey, this is end of life. You can buy it at your own risk. So I don't know if they might have some leftover stock where you can purchase one. If you're interested in IoT and embedded system hacking, this is a really great system to look at and to really consider digging into. Not only are there the vulnerabilities which I've covered, but I'm real confident there are others in there. Some of the way in which it's processing data and returning information, I would not be surprised if there are far more issues that I did not uncover. So with that, I'd like to say thank you to everyone. Open the floor to questions, and before, if you don't get to ask a question now and you want to ask one, feel free to pull me aside during the show. My LinkedIn is there. Reach out, just be like, hey, I'm from Hack Miami, so I know you're not some random recruiter trying to get you the deal of a lifetime. And if you're interested, the code is hosted on my GitHub. It has the full exploit code, and I think I have the right up there as well. There's also a number of other projects that are there. Don't look at those, they're bad projects. I'm not very good at maintaining things. But definitely take a look at this one if you're interested. So thank you. So are there any questions? If not, thank you to all of you, and thank you to Hack Miami.